Okay, so welcome to Sharm-El-Sheik International Airport. Um, so I want to try and do a little quick flight. Well, it's not going to be so quick, but hopefully be quite interesting. It's a flight from Sharm-El-Sheik on an Easyjet A320-200 series to Luton, and it's going to be live on the VATSIM network, but it's quite late at night, so it's actually 10 to midnight in London at the moment. Anyway, this is the airport, and what we'll do, we'll jump in and we'll see if we can see anything. Quite interestingly, as we move about, I don't know if you can see the aircraft if we start moving towards it, but it's absolutely pitch black here in Egypt, and you know, there's really such little light pollution. You can actually see a very nice view of the night sky. We've got this beautiful moon over here, and I don't know if you can see it, but you've got Orion, and you've got the Orion's belt over here as well, so you can actually get a really beautiful view of the night sky. So what we'll do, we'll jump in the cockpit and we'll start getting ready for the flight. Okay, so we're in the cockpit, and it's absolutely pitch black. You cannot see a thing. So what we're going to do is just going to go over and oh, there's a car over there. And what we'll do, we can see these are the voltages of the two battery systems. So as long as it's above 25 volts, we can turn each one on. That's one on, and that's the other one on. So now we can see a few lights. Everything is still very dark, apart from the electronic flight bag that we've got over there. We've got a few systems on. Okay, still looks bit eerie. And what we'll do, you see this green button available, that means we've got ground power available, so we'll just turn that on, and then we can start to see everything starts to come to life. So here we go. Welcome to the flight deck, and the other thing we're going to want to do is a few things just to get things going. We've got the self-test in progress for all the different displays. What we're going to do first of all is just get a little bit of light. So we've got full brightness over here like that, so that's better. We're going to turn on the overhead backlighting. We're going to align the IRSs, the Inertial Navigation Systems, over here. And one of them is for the first officer, the other one is for the captain, and the other one is a backup. The other thing we're going to do is turn on the emergency exit lights, arm those, set the no smoking to auto, and we're going to turn the navigation light to system 1 or 2. Doesn't matter which one. One is a redundancy, so we'll keep it on 1. And we can also leave the wing light off for now. Now, crew oxygen supply is very important, obviously. So if we come over here, we can see the oxygen masks, and we can do a test. So if we push and hold, one for the captain, one for the first officer, nothing's coming out. We haven't got any oxygen going there, which is no good. So we'll just turn the crew supply oxygen on, and now when we come over here, we can do that, and that's very, very important. Okay, so we've got oxygen. Another thing is it's very important to take these out and to actually put them over our face, and to adjust them to make sure that they fit properly, because we don't want to be doing that in a real emergency of cabin depressurization. So that's not going to be any good. Okay. So, any other things just to get started? There will be. So, let's have a look. So, right. So we've done the emergency exit. Seatbelt sign are on. Sorry, no smoking is on auto. Seatbelt signs must be off. That's really, really important. And the reason why the seatbelt signs have to be off is because if there's a fire during the refueling stage. So just to make sure that you can see that, okay, we can see the seatbelt signs are off. If they're on, they would go like that. Okay, but we'll make sure that's off. No smoking is on auto. Nav on. Another very important thing to do as well is to make sure that the fuel pumps are off, which they are. during refueling, we're going to have to do engine fire test as well, so we'll just push and hold that. Good. Engine 1 fire test is fine. The APU fire test is good, and we'll do an engine 2 test. And another thing we'll do when we push and hold that, and come down over here, we've got the master caution on as well, which is all good, which is what we want. So that's seems to be working okay. Any other things that we need to do? We're going to turn the packs off, the air conditioning packs, and the engine bleeds off as well for the time being, and we'll just reduce the temperature in the cabin a little bit as well. Okay, so that is all looking fine. Okay, next thing that we're going to do is adjust the brightness displays over here, okay, because if they're too bright like that, can you see you've got so much glare, which is no good in dark conditions like we have now. So we're just going to turn that down, and we're going to adjust that one as well. We've got the ADIRs which are aligning again up here, so that can take about a good 10-15 minutes to do or so. This is our backup secondary flight display really. And then we're going to adjust the brightness on these ones as well. Okay, we don't want it to have too much glare. The ECAM display, again, we can set that's alright, okay. We can turn that down a little bit, this one down a little bit more. What else? Flood panel can be on very, very gently. And the integrated lighting, we can turn that up. And the flood panel, we can turn that on a little bit as well. Okay, so that's very good. Next, we have to check that the throttles are idle. Climb detent idle. Spoilers neutral, flaps neutral. Okay, parking brake is set and on, and we can open the door as well. Okay, it's nice actually because we've got an Easyjet cabin over here. Okay, so the first thing that we're going to do is just go to our, in fact, I'm just going to reduce the brightness on this because it's really, really very bright. This is our electronic flight bag. Okay. So what we can see over here is that we're meant to be departing in 34 minutes. Okay. And what we'll do is that we'll go to our FMC. First of all, check that we're in the right aircraft, CFM56, that's the type of engines, the correct AIRAC database, so that's our navigation database, 5th of September 2024, 2nd of looks like 20th of October 2024, that's fine. That's all good. Okay, initialization, and we'll do an init request. And also the first officer will want to update the ATSU menu as well, so this is actually, I'll go to the MCDU. We'd like to initialize this if we can. Here we are, flight initialization. Okay, and what this is doing is it's basically updating the data link from dispatch, which is obviously really important. Meanwhile, what we can actually do is start to get the passengers on board. So we'll go ahead and do that. Let's go to ground services. We've got the GPU. That's the ground power unit, by the way, which allows us to connect, fire up the aircraft basically without starting any engines ourselves. Okay, we'll go to the mass and balance, and what we'll do, we'll start loading the aircraft in real time. Okay. Left door is open, and the forward stairs over there as well. Okay. The other thing that we want to make sure of as well is that we can hear what's going on in the cabin and on the PA. So we can. So this lets us hear what's being said in the cabin. The other thing, while we're in the radio stack over here, we want to make sure that we're on the right frequency. So Unicom, which is the standard monitoring frequency if there's no air traffic control services, is 122.8. And we'll check our VHF2 is 121.5. That's the emergency guard frequency. We want to be able to monitor that, so we'll turn VHF2 on. Okay, but we're only going to be transmitting on VHF1. If we want to transmit on the secondary, we'll go like that. Okay, so we're on VHF1 over here, and then we'll switch back to VHF1, and then we can switch between Unicom and the secondary standby frequency. Okay, we can turn the cabin down a little bit over there. Okay, so that's all looking fine, and the passengers should be able to start board. Well, they are actually starting to board right now. Now, the next thing we want to do is start filling out the FMC, and the other thing that we want to do as well is that now that we've got our dispatch over here, we can go into the ATSI menu. AFC menu, check in your received messages, and we've got our preliminary load sheet. That's going to be very, very important. So that tells us, well, we'll go through that, but that's our initial load sheet, all our weights and balances of the aircraft. And that, again, was sent to us via dispatch. So what we'll do, we'll actually just dive in and have a quick look at that right now. So it says here, edition 1. Easy 2612. This is our call sign. Stroke 26. And that's the date on the 26th of September, 2024. SSH to Luton, Sharm-El-Sheik to Luton, and this is the registration of the aircraft, Golf Echo Juliet Charlie Delta, and we have to check that that actually matches the real registration of the aircraft, which is found just over here. Okay, so that's very interesting. That we've got basically means that dispatch, we've got into the right aircraft. Sometimes pilots actually don't get into the right aircraft. It's quite funny. Well, not really funny, but anyway, yeah, that really happens in real life. So we're in the right aircraft. Our zero. Now, here are the really, really important things. Okay, so ZFW means zero fuel weight. That's the weight of the aircraft with no fuel on board whatsoever. Okay, it's not the dry operational weight, DOW. Okay, dry operational weight is the weight of the aircraft with nothing on it whatsoever. So this is basically what dispatch thinks the aircraft is going to weigh once everyone and all the cargo is on board, without basically everything, the whole weight of the aircraft without any fuel on board. 56.4 tons. Okay, so that's 56,379 kilograms. So we'll round that to 56.4 tons. Now, the maximum zero fuel weight of the A320-200 is 61 tons. Okay, so we can see we can actually afford to put on, in theory, okay, about another 4.5, 5.5, about what's that? Yeah, so that's about nearly 5 tons more of payload, of cargo, right? But we have, so anyway, so let's carry on. TOF, that's our take-off fuel. So that's how much fuel we should have at taking off. Okay, that means we're going to be burning a very small amount of fuel, as we approach the runway kind of thing, and taxiing and using the APU. TOW, that's our takeoff weight. So if we take our zero fuel weight, remember that's the weight of the entire aircraft, all the passengers, all the cargo, without any fuel on board, and we add the takeoff fuel, how much fuel we expect to have just before we take off, that's going to be 16 tons of fuel. So if we add those together, that's going to give us our takeoff weight, how heavy the aircraft will be on takeoff, 72.5 tons. Okay, our maximum takeoff weight is 73.5 tons. So we're approximately 1 ton below our maximum takeoff weight. That's going to be very, very important, and that's going to be our limitation over here. That's what the L means, okay? And then we have our trip fuel burn. So we expect to burn 13.1 tons of fuel. So if we subtract that from the takeoff fuel, we'll end up with our landing weight at 59.3 tons. and the maximum landing weight is 64.5 tons. Okay, so that's going to be fine, and will be underweight by about a good 4.5 tons on landing, assuming we don't take any more fuel. Now that means we have an underload of 1 ton. Okay, the underload means what is our limit, the difference between our limiting value. So can you see over here, our takeoff weight is very close to the maximum takeoff weight of the aircraft, 72.5 tons. The maximum takeoff weight is 73.5 tons. Okay, so that's about 1 ton difference. So that's where the underload is coming from. That means that we can take a maximum of 1 ton extra of fuel, and that is it. Otherwise, we're going to have an overweight takeoff. Okay, we can't take off with that amount of fuel. All right, that's really important value. 1 ton. Okay, just over 1 ton. Our passengers 0/130. Okay, so that means the number of crew. Well, that's not. We don't have no crew on board, but we've got 130 passengers. Okay, and then we have some other values over here. Our Mach 0 fuel weight. That means the mean aerodynamic chord 0 fuel weight. So that's basically like the center of gravity of the aircraft during its flight, and the Mach takeoff weight on takeoff is the center of gravity of the aircraft at takeoff, which is obviously going to be different. Okay, and then we've got A45, B41, and C44. That's going to be the number of passengers in the forward, mid, and the aft sections of the aircraft. Okay, so if we're happy with that, and we have a few other interesting things over here in the other pages, but I'm not going to go into that right now. So we are actually loading on board 16.1 tons of fuel. I'm happy with that, and we've gone over the most critical parts that we have to be aware of, so I can accept that. That's absolutely fine. So what we're going to do is going to our MCDU over here and enter our flight number. Okay, now to do that, we're going to need to go to our flight plan. All right. So I am hoping that this is going to work. Do forgive me if it's all a little bit up in the air. So we'll go to our operational flight plan. Now hopefully that has brought up the operational flight plan for you. So you should be able to see that. Okay. So let's have a look. So this is our operational flight plan. This is the flight number, U2, which means Easyjet. U2 is always Easyjet. Okay, 2612. That's what the passengers will see, and the call sign of the aircraft, okay, is Easy 2612. This time it happens to be the same. They hardly ever are in real life. All right, we're going from Hesh, SSH, which is Sharm-El-Sheik, to LTN, which is Luton, and this is the international standard code for those airports. Hesh is 3 hours ahead of Greenwich Mean Time. Luton is 1 hour ahead of Greenwich Mean Time. Okay, so that's really quite important to bear in mind. And we're calculating this. This was issued at 22:38 Zulu time. Zulu is GMT. Whoops. For an estimated time of departure at 23:30 Zulu. Okay, so in Sharm-El-Sheik, that's 3 hours ahead. So that's 2:30 in the morning. All right, and in London time, it's 12:30. Okay, at night. All right, very good. So all of this is fine. This is the aircraft that we're in, the Fenix A320 CFM engines. Okay, the A320 does come in an IAE variant as well, which British Airways use. Easyjet do not. And this is the registration of the aircraft, which we checked. Do you remember before, which was okay? Golf stroke Echo Juliet Charlie Delta, which we come into the aircraft, which we saw on the where was it now? On the base plate. There it is. Okay, we can see it just over there. All right, so that's that's all good. Now, let's have a look. So, most important things, our flight number, okay? Easy2612. Our cost index is 4, okay? So the more cheap the airline, basically the more efficient, you want it to be, the lower the number, and the smoother, less efficient you want the aircraft to be, the higher the number. Okay, so that basically adjusts how fast the aircraft will kind of descend and climb. More uncomfortable for the passengers at lower cost indexes, but cheaper for the airline. So EasyJet has 4, I think BA is a lot higher than that. Our cruise flight level planned for today will be flight level 340. Cruise temperature will be minus 39 degrees. Our tropo altitude is 52,803 feet. Tropo altitude is interesting. So what happens is that as you climb, the temperature gets colder and colder. It starts to drop up until the tropospheric altitude. Okay. After this altitude, what happens is very interesting. The temperature starts to increase again, gets warmer. But we're not going to be anywhere near 52,000 feet. But anyway, interesting to know. The aircraft also wants to know that as well. The zero fuel weight should be 56.4. Now, that should align with what we got from dispatch. So, if we go and have a look, zero fuel weight, 56.4. Yes, it does. Perfect. Anyway, yeah. So that's good. Let's bring up the operational flight plan again, and yeah, okay. And we've got a trip wind of H14 knots. Okay, that means a headwind of 14 knots. So we're going to have an average wind component which is going to be against us going out to London this morning. Okay, so that's very good. We've got a standard block time estimated at 23:30, as we said, and we're expecting arrival in London Luton at 5:20 Zulu time in the morning. So that will be +1, so that will be 20 past 6 in the morning. We'll be expecting to arrive. Okay. Very important, this line over here, all right? This means maximum shear rate. This is extremely important, and in fact, that is dangerous. I would say that's dangerous. Shear rate means basically how much turbulence there is. Normally, you'd expect a value of like 1, 2, maybe 3. 10.1 is extremely high. This means an enormous amount of turbulence, and rest T is the waypoint at which that is going to occur, your maximum shear rate, which basically means we have to pay very, very careful attention to the weather going out to London this evening. Now, let's just have a look over here. Our estimated dry operational weight. Okay, so this is the weight of the aircraft, of the A320, without anything on board, 44 tons, all right? So really, this is, just to make this clear, 44,029 kilograms. 1,000 kilograms is 1 ton. So we have here 44 tons. Our payload, okay, this is the weight of all the passengers, should be 12.4 tons. So if we add the dry operational weight and the payload, we end up with the weight of the aircraft without any fuel on board. That's obviously our zero fuel weight at 56.4 tons. This is exactly what we got from dispatch, which is good. We then, dispatcher then allocating 16 tons of fuel. Okay. Now, this is the amount of fuel. This amount of fuel is going to be different to the actual fuel that we're going to be taking officially over here. Okay, 16.163. This is 16.082, and the reason for that is because this calculation over here is the fuel that we're going to have on takeoff. Before we take off, we're going to be burning a certain amount of taxi fuel, which is why the taxi fuel is considered over here. Okay, that's why these values are different. Fuel over here, this is our takeoff fuel. Okay, and that's really important that we look at our takeoff fuel, because we want to work out our takeoff weight over here. Okay, so our takeoff weight is going to be our takeoff fuel plus our zero fuel weight, okay, which is 72.5 tons, and this is going to be limited by our maximum takeoff weight, 73.5 tons. This is the limitation, because the difference between these two values are smallest, okay, which means this is our limiting value. All right, that difference then gives us the underload, all right, which is actually very important. Okay, that's 1 ton, which basically means that we can afford to take an extra 1 ton, either extra 1 ton of fuel or an extra 1 ton of payload, 1 ton of passengers. Okay. Actually, when I originally got this dispatch got this load sheet from the dispatch, it was actually more passengers. There were 180 passengers, and I actually said, well, why can't take 180 passengers? Because if we took 180 passengers, we would then be limited by our zero fuel weight, and that extra ton would be taken up, our underload, by our payload, and we wouldn't be able to take an extra 1 ton of fuel, and I want to be able to take an extra ton of fuel. You'll see why later, but anyway, that's really important that we've got an underload and a limitation on our takeoff weight. Okay. Then if we estimate our trip burn, this is the amount of fuel that we're going to burn, as 13.1 tons, if we subtract that from our takeoff weight, that should give us our landing weight. Okay, whoops. 59.3 tons. And our maximum landing weight is 64.5 tons, so that is absolutely fine. And even if we take an extra 1 ton of fuel, our landing weight will just be 60.3 tons, which is still over 4.5 tons. Well, still about 4 tons under the maximum landing weight, so that's all fine. Okay. So with that, let's go and insert our flight number. I am just going to check that you can see everything that I'm doing over here. Yeah. Okay. So basically, what's our flight number? EZ2612. Okay. So we'll go down here. EZY 2612, and we'll insert that in the flight number, and our cost index is 4 for Easyjet. Our flight level was 340, and the temperature at 340, what did we say it was from dispatch? Minus 39. And we can enter in 39 over here. We don't need to put the minus symbol in, because the aircraft knows that it's obviously going to be negative temperature over here. Okay, so that's all good. And then what we'll do, we'll go into the wind and we'll do a wind request. Okay, so that's going to basically download the live weather winds for all the phases of the flight, and we can just check that all the different flight levels, and this is going to be used by the flight management systems to determine all different things. Okay, so the IRSs have initialized, and what we would do is that we would check the positions of the IRS 1, 2 and 3 to make sure that they reflect the gate or the stand that we're actually sitting at the moment. So you know what, let's actually go ahead and do that now. Okay, so this is our these are our charts over here. All right, so we'll go into our airport charts, and we'll go into the taxi charts. Parking stands. Okay, parking stands are over here. All right, so can't remember what stand we're at actually. I think we're at Terminal 2, around stand 20. So what we'll do is that we can actually pin that to the flight flag. Parking coordinates, okay. So I think around stand 20, we're at north 27, 58.9. So what we'll do is check that. Okay, north 27.58, north 27.58.7, north 28.58.7, here we are. And east 34.23.3. 34.23.3. So that will cover us through stand 34 to 36. So yeah, we can see in our elevation is 156 feet as well. So we can see that our IRSs are aligned and the aircraft knows where it really is in real life. Okay, so this is what you would really do, and then check the stand and check the coordinates over here. Okay. So we can take away the charts for the time being. So now that we've checked the IRSs and the wind, our tropospheric temperature level, we also need to check that on our charts as well. So we'll bring up the charts again. Sorry, our operational flight plan I meant. And our tropospheric altitude was 52,803 feet. 52,000. Okay, that's all fine. And we'll check the ground temperature as well. In fact, we can do that now. Okay, so to do that, we'll go into the weather, and we've got the ATIS, the Automatic Terminal Information Service. Okay, at Hesh, 26th of the month at 2300 hours, 320 at 3 knots. Kavok. It's fine, that basically is normal. 29 on 20, QNH 1007, and no significant weather. This is nice because it breaks down the temperature for you. So we've got a ground temperature of 29 degrees, and our QNH is 1007. So we'll enter that in now. So that's 29 degrees. And our QNH was 1007. Slightly low pressure, and that has to be obviously checked on here and checked on our backup 1007 as well. This is our backup display, so we can also fly the aircraft on this if our primary displays go. We've got a landing system as well. We also have bugs as well that we can put on there, so we can effectively land the aircraft just with this thing if we actually need to. Okay, so the next thing to do is to go into the initialization page 2, and we are going to tell the aircraft what the zero fuel weight we expect to have. Okay, so from our dispatch we had 56.4 tons, 56.4, with a center of gravity of Mach zero fuel weight 30.2. Now that may change after the passengers have boarded. Okay, yeah, so the next thing that we want to do is put in our taxi fuel. Okay, so we've got 81 kilograms. We'll round that up to 90. Actually, you know, we'll put 80 in there. 80 kilograms. So that's going to be 0.1 would be 100. So 0.08. And that's okay, 0.1, that's rounded it, alright. And then what we need to do next is actually, before we do the fuel planning, is going to our flight plan and actually tell the aircraft where we're, you know, how we're gonna, sorry, we need to tell the aircraft our standard instrument departure and standard terminal arrival, because the flight plan has been loaded in from ACARS. In real life you wouldn't have to enter all the whole thing. Okay, so let's select our departure. Now, in order to figure out what our departure is, we need to tune into the automatic terminal information service, or we need to go and have a look in our charts. So the weather, we've got ATIS. Have we got any real ATIS at the moment for Sharm-El-Sheik? We have not. So we'll use the, this is from the central online live weather, QNH 1007. Winds 320 at 3 knots. Now, if we have a look at the ground chart, what we can see, we've got a nice long runway, 10,100 feet, or just over 3 kilometers. So it's a nice long runway. And if we imagine, we think about this, the wind coming in at 320 degrees, so it's going to be coming in from over here at 3 knots like that. There's going to be a crosswind, okay, but it looks like, my guess is that we'll be on 22 left or 22 right going this way, because that will help us fly into the wind. So we can just actually check that on our information runways. And oh, I was wrong. 4 left or 4 right. Yeah, it's going to be very close, because there would only be a tailwind of 1 knot component using those runways. So 4 left or 4 right. It doesn't matter which one. Obviously, we would be assigned by air traffic control if they were online. So what we can do is just have a look at our flight plan and see if we have it in there. Runway, oh, we've actually got runway 22 right programmed in there. So what we can do is actually just remove that runway from our chart. Remember, this is from our charts. This is our electronic flight bag. It's not anything to do with the aircraft. So 4 left or 4 right. So to determine which one, how would we go about doing that? Well, what we can do is that we can check our flight plan over here. So let's go into our flight plan and see. This is actually selected 22 right. Okay, so that doesn't help at all. But we need to get to Kupti. That's the first waypoint, is Kupti. Okay, now that is important. So let's have a look. 4 left or 4 right? Well, 4 left is going to be nearer. I don't think there's any significant reason why we can't use either. But in the absence of air traffic control, it really doesn't make any difference at all. So what we'll do, we'll go to the procedures of the airport. In fact, we don't need to do that. We can just select. Let's select a departure that will get us out to Kupti. Okay, so these are all the departures from Sharm-El-Sheik. Runway 4 left, runway 4 left to Kupti. So it looks like we want to be using runway 4 left to Kupti. Does that look good? Well, let's check it out. So that will take us up to Kupti, which is what we want. And runway 4 right or 4 left. So it actually doesn't make any difference at all. So we're going to add that one to the route, and we'll select runway 4 left. Okay, so that's been added to our route. Now, these numbers here are really, really important. Can you see they go green and then red? So that means 8,200 feet, 7,800 feet, 11,500 feet. This is the Mora altitude. Mora. Minimum off-route altitude. Mora. So if you have to divert or go off-route for any reason whatsoever, the minimum safe altitude will be this number over here. So 11,500 is very high, because obviously it's going to be very, very mountainous over here. All right. Now, if we go to daytime viewing, we can select a terrain view, but basically there's a lot of terrain over here. Okay, now if we go to the actual standard instrument departure that we're going to fly, which will be the Kupti 1 Lima, I believe. Kupti 1 Lima. What's going to happen is that we're going to fly on the runway heading, and then go for an immediate turn to 023 degrees up to SH640, and we have to be above 3,000 feet over here. Okay, we're then going to turn to 357 degrees, almost north. We'll have a 6-mile track to SH641, where we have to be above 5,000 feet. We're going to turn on heading of 292 degrees to SH643, where we have to be at flight level 120, not above or below, at 120. So this will be an altitude constraint. And then we're going to head at 291 degrees, a 30.8 mile track distance to Kupti, where we have to be above 18,000 feet over here. So on the standard instrument departure, you can actually see the terrain, okay? So we can see also the Mora altitude as well. 11,500, this is obviously very, very steep over here. We can see mountainous regions over here. We've got an 8,577 point over here. So we should be able to see that. Well, it's night, so we won't see that. But during the day, you'd be able to see a lot of mountainous terrain. And we're literally going over this mountain ridge over here as well on the departure. This is the Strait of the Sinai Peninsula, I believe, as well. So yeah, so we're going to be flying over that and then heading off out to Kupti over here. But critical points on this departure is that we really want to have an accelerated climb, maximum climb, you know, and we have to obey these altitude constraints. So that's really, really important. So let's go back to the aircraft and make sure that we enter that into the standard instrument departure. So we're going to be selecting 04 left for the Kupti 1 Lima. 04 left, Kupti 1 Lima departure. So that's good. I'm going to insert that. And what we can do is just come up to the plan page, set our constraints on, zoom out to 40 nautical miles, and we can actually start to pan through and just check that's all good. SH640 at above 3,000 feet, above 5,000 feet SH641, at flight level 120. So you see this magenta is a fixed altitude, not plus. All right, SH643, and then Kupti above flight level 180. So that standard instrument departure is all set, and that looks absolutely fine. QNH changed to 1008. Okay. So that is all looking good. Next thing we want to do is insert our arrival information into Luton. So to do that, let's check the weather information at Luton. So Luton weather. Okay, so Luton is actually not so good. We've got a lot of broken cloud at 1,500 feet. CB, which means cumulonimbus clouds, so possible thunderstorms, very low pressure. So that's typical of very thunderous activity. And that was occurred 17 minutes ago. All right. So let's check the winds. We haven't got very strong winds, no gusts, so that's good. 230 at 12 knots. So imagine 230 at 12 knots. So we're looking at the wind is coming in that direction. So if I can actually just draw that, the wind is like going in this direction over here. So which means that we want to be landing in that direction, so that we've got a headwind rather than a tailwind component. Okay, so I expect runway 25, and just to make sure, yes, we can see that runway 25, green, crosswind and headwind. Okay, headwind component will be 11 knots, crosswind component 5 knots, which matches with the information that we've got from here. Okay. Runway 07 would give us a tailwind of 11 knots, so we definitely don't want to use runway 7. So at the moment we'll select runway 25, and we can just make sure. So runway 25 has already been selected in our charts. So what we can do is that we can go to the aircraft and select ILS runway 25, and then we obviously need a standard terminal arrival as well. So let's have a look at Luton arrivals. So first of all, let's have a look at the procedures. Going into Luton at runway 25. So these are all the different procedures that we've got, and we're going to be entering coming into Zagazoo. I think, is that right? So I know what's happened. No, I don't know what's happened. So these are the arrivals, runway 25. Now, why haven't I got... Oh, these are departures. Sorry. Arrivals, that's better. Runway 07, runway 25. So, out of all these arrivals into Luton, which one do we want? Well, our route is going to take us to Rennes, which is the boundary between Amsterdam Control and London Control. So it makes sense, the Rennes 1 November. And we can just check that. So yeah, we've got Rennes, and that will take us all the way into Zagazoo. Rennes 1 November. And it looks like that's already in our flight bag over here. Yeah, the Rennes 1 November. Good. So, let's have a look. Yeah, so this is the Rennes 1 November overlaid, and this is the chart. So the Rennes 1 November, we'll select that on our FMC, MCDU, Rennes 1 November, there you are. Rennes 1 November, and we'll enter a VIA. Okay. Checking you can see all this alright. So the VIA will be... let's just see. So just to recap this, so Rennes... well, actually, let's just have a look. So that will take us to Zagazoo, and then we need to select an approach. So we can take the Zagazoo 1 Tango ILS. It looks like that's going to be fine. Yeah, and that's going to really complete our route. See, that's Abbott. We don't want to go via Abbott. Approach, runway 25, Zagazoo 1 Tango. That's what we want. We're going to be doing an unconventional approach here, because the conventional approach will be going via Abbott. We're going to be going via Zagazoo. So we actually want this one. Zagazoo 1 Tango, and that's going to take us from Zagazoo all the way to FITME, and then from there we're going to be able to select the actual arrival. Okay. Runway 25. Which is... well, it should be one of these things. It's not. There we go. So we've tagged that in our flight bag now as well. Okay, conventional approach. So let's go into our MCDU and enter the Zagazoo 1 Tango transition. And we'll insert that. And just as before, we'll check constraints are selected. We'll check that this is all entered correctly. So we'll go to our flight plan, we'll just cycle through all the pages. Okay, so here we are. Our first constraint is at Renus at 22,000 feet. And then Idesi at 18,000 feet. Zoom in a little bit more now. $14,000 at 250 knots, constraint. Koku at 220 knots. And then Zagzu, 8,220 knots. And then we would just check that against the charts that we have, and all these constraints are absolutely fine. So I'm happy with that. And that flight plan seems all good. So now that we've done that, now that the plane knows what our flight plan is, looks like we've finished refueling as well. Now that refueling is actually completed, what we can do is we can turn on the seatbelt sign, because there won't be a fire in theory. And what we're going to do as well now is just turn on the APU. And we should see the APU start to come alive, because the APU is an engine at the back of the aircraft, and we should see the N limit start to increase. And what that's going to allow us to do is to take electrical power instead of coming from the external power supply from the APU generator over here. And this percentage is going to start going up. And then once we've got APU power, we can start to also provide bleed air into the engines in order to start the engines as well. Okay, so we can have ground air to do that, but usually done by the APU. And then we can start putting air into the cabin as well. So let's just keep an eye on the APU, 45%. This is the exhaust gas temperature, EGT. Here we are. So we've got 400, coming up to 400 hertz of AC supply at 115 volts. We've got no bleed air coming through at the moment. So if we go up to our panel, we can turn on the APU bleed, and we can turn on packs as well, and engine bleed as well. Okay, now that that's done, we've got bleed air coming into the engines, which is good, which means that we'll be able to start the engines. Electrical power, we can now transfer electrical power from the external power to the APU, and we're going to do that just by turning off the external power, and hopefully we'll be able to see, yeah, that's been transferred to the APU. So actually, another thing we can do is that we can come across, oh, the aircraft has been loaded, that's good, and we can push away the ground power unit as well, because we don't need that no more, that's now unavailable, which is good. Right, let's get on. Now, now that the aircraft knows the route, what we can do is that we can enter our, oh, we forgot to enter our alternate as well. So I'll show you what that does. So our operational flight plan, the amount of fuel that we are going to need to get to our alternate will be 1.3 tons, okay, or 34 minutes. That's if, and that's at Manchester. 139 nautical miles from Luton, and we'll climb to flight level 180 if we need to get there. Now, this may happen if the weather turns out to be really bad at Luton and we want to divert. We're going to need 1.3 tons in our alternate reserves as well. So we're going to go ahead and enter 1.3 tons for our alternate. Final reserves at 30 minutes, or approximately 1 ton. Reserves at 5% of our trip. And based on this, we can do an initial fuel planning. So the aircraft is now going to calculate what it thinks it needs to be able to get to Luton safely. So final reserves 1, trip 12.9. So our minimum destination fuel on board, alternate plus final reserves is 2.3, 15.8. Now, what did we decide to take? 16.1. All right. Is that right? 16.14. And here we are. Takeoff weight is now 72.5 tons, which gives us an underload still of 1 ton and an extra time of 9 minutes. Now, remember we had that underload of 1 ton, and that's really important because what I am going to do is, instead of accepting this load sheet, I am going to request an extra ton of fuel. Can I do that? I can. Why? Because, sorry, I keep forgetting to take this off. Sorry that you couldn't see that before. In the final load sheet we have 56.4 tons, 56.4 tons, plus 4, I think that's the crew. Takeoff weight 72.5. Takeoff weight 72.5. That's because we told the aircraft we're taking 16.1 tons of fuel, which is over here, which is a little bit more than it thought we needed. How much more? 9 minutes of flying time more. So this is in addition to the time it's going to take us to get to Manchester should we need to divert. It's in addition to our final reserves, which is our absolute, where we would declare an emergency, fuel emergency, so we don't want to go anywhere near that, and ignoring taxi and reserve. So taking all of that into account, we're going to have an extra 9 minutes. Now, based on the weather in Luton, which is pretty bad, I want to be able to have holding time, and I want to be able to have the ability to do a couple of go-arounds. So if we say each go-around will take 20 minutes, that will add 40 minutes to flying and 20 minutes of holding. That's 1 hour extra flight time, okay? Which will correspond to about 1 ton extra of fuel. So what I'm going to do is that I'm going to request the last minute 1 ton more of fuel. All right. So 16.14. We're going to do 17.143. Okay. And just before we do that, we're going to do a sanity check to make sure that we can do that. So let's go to our operational flight plan again. If we take 1 ton more of fuel, well, we can take an additional 3 tons in theory, but we're limited by our takeoff weight, which is an underload of 1 ton. So this should be absolutely fine. So if we take 1 ton more fuel, we have a gross weight now, which is now 73.5 tons. Okay. So we really are at our maximum takeoff weight now. Received messages. And what we're going to do is request a final load sheet. Okay. And the final load sheet should now take into account an extra ton. So expecting our zero fuel weight to be the same, our block fuel will now be 17.14, which should give us an extra about 1 hour more of flight time and take our takeoff weight to 73.5 tons. 73.4 tons, which gives us, in fact, that's only 37 minutes of extra time. Okay. Sorry, so it's 1 ton that gives us 30 minutes. Okay, so this is really the maximum amount of fuel that I can take now. Because remember, if we go back to our operational flight plan, we can see that our fuel now is at 17, just over 17 tons, which is going to take our takeoff weight to 73.5 tons, which is our absolute limit. So what we're going to do is that we're just going to request a final load sheet from dispatch, resend load sheet, and there we have it at 23:58. Our load sheet, this is our compliance with edition 1. Zero fuel weight 56.4, takeoff weight 72.5. There we go. Oh, that's not correct. 72.5. That should be 73.5. Let's just check. Okay, there is a mistake over here. It has not recognized that we have more fuel in the tank, 16.1. That's why it's made the mistake. Planned in tanks. Right. If we put 17 in here, that's not correct. That should actually give us a correct load sheet. Takeoff weight 72. If we just accept it, let's say. Yeah, this is not right. Because what should happen is that when we resend the load sheet, it should have 17 tons. It should recognize that. Gross weight here. See, it's recognized it over here. 73.5 tons. It hasn't accepted it. Okay. Anyway, so that is a bug. That should say 73.5 tons. Yeah, fueling tanks, that is not correct. Okay, but at least we know what's what. At least this is correct. So the zero fuel weight is 56.4. Our block fuel is 17.1. Takeoff weight is 73.4, and that is calculated based off our original flight plan, limited to 73.5, and our extra fuel 1.3. So we have 38 minutes of holding with no go around, or we have a couple of go arounds in there, maybe two go arounds, or we can maybe do one go around and then go up to Manchester if the weather is really bad. So we've got a little bit of fuel to play with. Obviously not much, because we're limited by really the length of the flight is so long, and we're very heavy. We're operating right at our maximum takeoff weight now. Okay, so this is all fine. So the next thing we have to do is actually prepare our performance takeoff checklist. So let's go ahead and do that. So let's come across to our departure performance. So we're taking off at 04 left, a dry runway. We can sync our load sheet, which is wrong. 72.5 tons. It's not. It's 73. 3.5 tons. We're at maximum takeoff weight now. Our MACTO, well, we're actually going to use this to get that information from. Our MACTO, we can't actually get it from there. Mach 0 fuel weight's 30.2. Oh well. What we'll do, we'll have to use what we got from our last dispatch. So basically, our MACTO is our center of gravity at takeoff, which is 26.4, and we can enter that in, 26.4, okay. And we're going to sync the live weather, QNH 1007, 29 degrees, winds 320 at 3 knots, okay. The next thing that we're going to do is select our intersection, okay. Now, in order to understand what the intersection is, we have to go to our charts again. Right, so our intersection. So basically an intersection departure is if we were not going to use the total length of the runway, let's say we're going to go from Bravo, we're only going to be using a shorter section of the runway. Okay, doesn't look like there is an intersection departure, which means that we're going to be using the full length of the runway, which is probably, you know, what we would like to do anyway. Okay. Let's go ahead and do that then. Yeah, so this says 3,081 meters, which matches what we have here, 3,081 meters. Each runway is exactly the same length, 10,100 feet. So based on that, we can select that, and then we're not going to have any shift, meaning we're not going to be taking off 300 meters down the runway or 400 meters down the runway or anything like that. So we've got the correct aircraft configuration for our takeoff weight, which is very critical, and our MACTO percent. This is our center of gravity at takeoff, not in flight. Live weather is synced. For left, 3,081 meters, width 45, 130. Okay, this is all good. We don't have a high elevation, so we can calculate what that will be. Got transition altitude 3,500 feet. Okay, so let's just check that all of these things look good. We're going to PAX off. If we have PAX on, what's it going to say over there? We do PAX on. So we'll probably want to do PAX off just to give the aircraft a bit more power. So basically what that means is that the PAX over here will be off for takeoff, and it basically means all the airflow is going to be used in the engines rather than the cabin. We can turn those on afterwards. Okay, so it just gives us a little bit more power on the takeoff. Flap configuration 1. Yeah, we have that over here. Force toga. Toga required. No. Okay, so toga is not required. Takeoff, go around thrust. So that's the maximum thrust that we can get, which we don't actually need. Okay, so just to show you what that is. So this is 0, climb detent, flex, and toga is absolute maximum power. We don't need that, so we're just going to go to there. Okay. And that's the reversers, right? So again, going up to climb, flex, toga. We can bring that to 0 now. Okay, as it should be. Okay, so this is all good. So we can actually send that to the MCDU, and hopefully we have that now here. V1 speed 150, 151, 153. Transition altitude 3,500 feet. Thrust reduction. So 1630, which is fine. Flaps 1 with a pitch up of 0.5, and shift will be 0 because we are at the head of the runway. We're not going to be 300 or 400 meters down the runway. So that looks absolutely fine. So the first thing I'm actually going to do is turn down the lighting over here. The critical thing is just to quickly go through our departure briefing from our charts. So we're going to be pushing back from stand 20, and we're going to be coming out this way. We want to be going that way, so we want to be pushing back, facing like that, okay, and then heading in that direction. And we're going to be, looks like we're going to be going on, we can go on taxiway Alpha all the way down to the bottom, turning left, and then lining up on runway 4. Alright, so this looks like a good plan. And then after that, yeah, so I'm just going to actually redo that on this one. An apron 3 on Alpha. Okay, that's fine. Right. Now, next thing is our standard instrument departure. Okay. So, again, we're going to be climbing 3,000 above that fix, 5,000 above SH641, at 120 by SH643, noting the terrain here at 9,000 feet, and above 18,000 feet by Cookty. Now, because there is no air traffic control online, we are going to be following the SID requirements exactly. Alright. So what I'm going to do initially is select 180 as our initial altitude constraint. Show you what I mean. The aircraft over here, we'll select that to 18,000 feet, and in managed mode that will obey all of the rules of being above and at and not above any of those restrictions. Okay, so we can switch this to ARC at 10 constraints, and the first officer side can go to ARC 10, and instead of constraints he can view the airports. We'll put the airport over here. Okay. Right. Radio navigation is automatically selected. The Airbus does this automatically. It changes the VORs automatically. Secondary flight plan, we haven't done that yet. So what we're going to do is we're going to copy the active flight plan, and then we've got our secondary flight plan. So we can go to our secondary flight plan, and we can enter in the emergency procedure, the engine out procedure. So to do that, again, let's think about this. So what we're going to do is enter a fix. We'll call it the engine out SID, and we'll insert that over here. So that says a new waypoint. It doesn't recognize it, obviously. And what we can enter it in 3 ways: lat, longitude, place, bearing, distance, or place, bearing, place, bearing. So that will be a place, bearing, and comparing that to another place and bearing. Okay. So we're going to do our airport, HESH, HE. SH, but a bearing of the runway heading at 04, so we need to check that in our charts. So runway 04. We have a look at an approach chart. 04, what is the heading? 039 degrees. So if we enter here, 039 degrees at 25 miles, and that'll be our Easyjet store. Now if we enter that here in our secondary flight plan, EO SID, should recognize it. There we go. And it's drawn where that is. So that's 25 miles on the runway heading. It's going to go to EO SID. And what we'll do is that we'll enter a hold at 039 inbound, right hand turn, that's fine, and after that what we'll do is that we'll head back to the airport, HESH, HESH, it's our new destination. And we can select arrival ILS 04 left. We're not going to do any star. And at that point we would get radar vectors back to the runway. So that is all fine. So this is our secondary flight plan. Just make sure that we're happy with it. So in the event of an engine failure after takeoff, we will head out on the runway heading 039, 25 miles from the airport, enter a hold, configure the aircraft for an emergency landing, and then head back to the airport at runway 04 left. And we can just get radar vectors to that, and the aircraft will then know that we are wanting to land on runway 04 left. Okay, so this will be our emergency procedure, and just to make sure that that is actually acceptable according to all the terrain, we'll just check the terrain on the ground at Hesh. Okay, and what we'll want to do is select our terrain feature and just check what kind of terrain will be at 25 miles. So we're going to be flying over the Straits of Aqaba. Cairo will be entering into Jeddah airspace and then turning around. So there's no significant terrain until we get really far away over here, and we're not going to be doing that. So we're going to be coming out over the coast and then heading back. We do need to be careful. Sometimes there's a non-standard emergency procedure if there was terrain and we need to take a right turn or something like that. And then we'll head back to the airfield where we can land as quickly as possible. Okay, so that all looks absolutely fine to me. This is the terrain that we're talking about on our SID, just going out, just to show you what that looks like. so we can really see. And just being very careful of our moor altitude. So if we do go off route for any reason, we cannot go below 11,500 feet. Okay, so I think that we have briefed enough for the departure. We'll go to continent mode. Okay. So I think we are ready. Yeah, okay. Secondary flight plan is fine. After 10,000 feet, we'll clear this and we'll do a copy of our current flight plan. So, normal flight plan, performance, ARC 2010. ARC 2010. Airport selected, constraints selected on the first officer side. Okay. So, let's just check our fuel and just check the balance here. We've got 4.6 tons in our center tank. We've got 5.5 tons in the left tank, 5.5 tons in the right tank. There's a little bit less here, and the reason for that is because our APU is feeding off the left, so it's not a problem. We can always do automatic cross fueling, which actually we've got that selected anyway, and on the outer tanks we've got 700 kilos in those tanks as well. Alright, we've got no fuel usage per minute at the moment, and our fuel on board is just over 17 tons. Our static air temperature outside is 29 degrees. Okay. So, that all looks good, and this is our gross weight, which we expect to be at 73.5 tons. Alright. So, that's looking good. We've got everyone on board, and we are actually not going to require a pushback. So I tell you what, let's just have a little quick walk around the aircraft and check everything's looking good. Do we have the wing lights on? That'll make it look nice. So it's actually a pretty quiet airport at the moment. There's no one else here. Remember, we are flying online as well. We're departing from stand 37. Yeah, 37 is our departing stand. You can just see what it looks like from the passenger's point of view over here. Okay, so 122.8, stand 37. Close the door, and what we're going to do now is lock the door. It was locked. And what we do ordinarily do at this stage is request clearance for the push and start. Sharm-El-Sheik traffic, Easyjet 2612s, type A320-200, pushing and starting stand 37 for taxi to runway 04 left. There we go, that's a little bit better. Okay, now if we are cleared to push and start, we're going to turn our beacon light on, so you can see what that looks like from the outside. We can turn our taxi light on as well, and We can also now turn our fuel pumps on. Packs on, engine bleed is on. Okay. Ignition, engine 1 start.
Cabin crew armed on cross-check.
We can now put the electronic flight bag away. I need that.
Ladies and gentlemen, please observe the cabin crewmen closest to you as we are about to demonstrate the safety features around.
What we can do as well is just review our taxi charts. Yeah, so we're going to be coming out and turning right onto Alpha and then all the way to the bottom, but we mustn't overshoot this because then we'll end up over here somewhere. So we'll want to be cautious to be observing the Charlie, Bravo and Alpha turn-off. Okay, so after engine 1 has stabilized, now start engine 2. There's our page over here, we can just observe that. The next thing that we can do while we're waiting is turn on our predicted wind shear. Auto, system 1, can be system 1 or 2. This is kind of adjusts our radar, which doesn't currently work in the simulator at the moment. But we do need to turn it on. So when we turn it on, you'll see one of the warnings go away over here. There we go. And we need to come across and we need to turn on our TCAS. Now normally our traffic control would assign us a squat code. We'll put 1200 over here. We're only interested in aircraft above us climbing, but it's not congested, so we'll select all. Standby TA, traffic avoidance. Okay. Standby auto. So that is all good. Engines have stabilized. We can now select mode selector to norm. We can now turn the APU bleed off and turn the APU off as well. We'll turn the taxiway turn off lights on as well, just because it's a little bit easier to see. Okay, very good. Now we'll select flap 1 from our performance, flap 1, and we have to have up 0.5 as well. So we'll go to our flight control page and our pitch trim up 0.5. We will then do a check: full left, full right, full up, full down, full rudder left, full rudder right, or the other way around. That's it. And now we have a gross weight of 73.4 tons. Okay, which is good. So that is all fantastic. And now we can start to begin our taxi. What I'm going to do is just select the chronometer and make sure that 3 minutes pass before we actually take off. Release the parking brake. And dim the cabin. And now we can increase some power and hopefully get off. Except we need to release the cones. There we go. Now we'll be able to go. Remember, we are a heavy aircraft at the moment, very heavy. Alright, and now let's begin our taxi. The reason why I did that chronometer over here, it's at 1 minute 25 now, is because you want to let the engine stabilize for 3 minutes before takeoff. So we just have to make sure that that happens. It's unlikely we're going to get to the runway center line before. Okay, we've got cabin crew telling us something.
Hi, Captain. The cabin is now secure for takeoff.
Okay, thank you very much, and we'll be in touch after departure. Go. So we're looking for the Bravo and then the Alpha turn off, which will be to the left. Now, if this was a better scenery package, the signpost I'm sure would be there a lot clearer. Oh, going at 30 knots, which is too fast for taxi. Get out my way, schmuck. Where does he think he's going? He's in front of mine. Anyway, got to be careful not to overshoot the taxiway here, because there's a part that actually goes to nothing. Yeah, that was it. That was the bit that went to oh bugger. Yeah, very, very confusing actually. Yeah, you see, if you got payware add-ons for the airports, then they're much better signposted. Okay, we can turn on all our lights. Strobe will be automatic. And we're going to hold short, turn our packs off, that's very important. Okay, so packs off, takeoff. Next, speed brake armed, auto brake maximum, takeoff configuration check, and alert the cabin. Good. Alright, so I think we're ready to go. Checking that our timer is now 4 minutes 52. That's fine. we can reset that. And let's get on the runway. Easyjet 2612, Sharm-El-Sheik traffic, lining up runway 4 left. Yeah, I can feel the weight of the aircraft, because normally under this thrust condition, even though it's only a little bit past idle, the aircraft would be going under its own thrust, idle thrust even. Okay. So, Coop T1 Lima. Good. Sharm-El-Sheik traffic, Easy 2612, taking off runway 04 left, Coop T1 Lima departure. Okay, let's take the engines up to 50%. Start the chronometer. Engine stabilized, no problems. Climb. Flex. SRS. Runway nav. Yeah, we are really heavy now. It's good that we've got such a long runway to use. Here we go. V1, rotate. Positive rate. Gear up. And coming to the left almost immediately. Help us see outside. Pack 1 on. Leave a climb. Engaging the autopilot. Pack 1 on, Pack 2 off. Lead air. Pack 2 coming on. Spree brake released. And flap 1 to flap 0. Actually, I don't want to do that. Let's bring back flap 1. No, we do want to do that. It's fine. Oh, that wasn't good. You see, what we want to do is really keep an eye on
fresh
That's our PA system.
Full details can be found in
That's what the crew is talking about.
You can also purchase a selection of hot beverages together with drinks.
Thought that was the radio.
Bar. We accept all major
So we're going to turn the displays down a bit now.
Any further assistance, just ask us as we join
You can really see the importance of actually turning the displays down so you can see it clearly. Three and a half thousand feet, standard QNH. We're in managed mode. And we're coming up to SH641 where we have to be above 5,000 feet. We're at 7,200, which is fine. Should have turned our terrain on. If we zoom out a little bit, our next constraint will be at 12,000 feet by SH643. And you can actually see that from the charts as well. So SH643 will need to be at 12,000 feet. And we'll be over here somewhere. Yep. Going up to here where we have to be at 12,000 feet, not above. And then after that we have to be above 18,000 feet over here. We might be able to see something out over here, some kind of mountain thing, but remember it is very dark outside. Passing 10,000 feet. Lights can come off, landing lights anyway. And we can turn the seatbelt signs off as well. Yep, it looks like we're going to make it to 12,000 feet. Now let's just say for argument's sake, air traffic control cleared us to 18,000 feet now. We can do that in an open climb, and that's changed from managed to open. So now we're breaking the constraints of the standard instrument departure, and we're going to 18,000 feet. And the blue line is where we're going to level off, which obviously now will be a lot nearer than it was before. Well, a little bit anyway. And after we reach SH643, we can go into managed mode again to any flight level we like, because this constraint is anything as long as we're above 18,000 feet. We don't need that anymore. Well, we've been going for 8.5 minutes. Passing 14,000. we can, now that we've passed SH643, we're going to Kupti, estimating Kupti at 12:52, 12:48, so in 4 minutes. We can now go back into managed climb, and that's changed from open climb to managed climb, obviously because there are no more constraints other than that we're above 18,000 feet when we get to Kupti. And what's being shown is that actually we're going to reach 18,000 feet quite a bit before. If we get clear to 19,000, you'll see the blue line go up, and that's where we'll reach 19,000. So actually what we can do is we can see what our most efficient cruise altitude is, 330, and go straight there and enter that as a new cruise altitude, 330, and that will affect all other altitude constraints on our flight plan. See, flight level 330, it's changed everything. So we can clear that to say 330. Managed mode, and we're going up to 330. 330, and we are above 18,000 feet now. So we're pretty much safe, and we are on our climb stage now. So from the first officer's view, let's have a little look out. My side, captain's side, let's see. Can't really see any. It's very dark. And then we can also select airports. And in our plan mode, we can zoom out to 160. We can see the different other airports that we've got. Hesh being over here, Sharm-El-Sheik, and a few others as they go along. miles. 80 miles. And you can see what's happening is that we've got center tank feeding going on at the moment, and that was because there was the imbalance at the beginning of our fuel. So you can see we've got a little bit more here than over here. Only 20 kilos, but it's enough to allow the cross feeding to actually be happening. So we should be able to see our cross feed is happening automatically. I think. Hydraulic system, engine feeding over here. Okay. Everything here is looking good. Fuel on board 15.7 tons. Okay. Burning 1.35 tons per... No, that's what we've burned. 1.4 tons of fuel. Burning 70 kilos a minute. Our gross weight is coming down. So what we can do now is that we can just do a couple of checks just to make sure everything is in order. So our next point will be Capit, and we're estimating Capit at 0101, okay, which is in 8 minutes time. Okay, so in 8 minutes, 8 minutes plus 14 minutes is 22 or 23 minutes. So if we go to our flight plan, remember that 22 or 23 minutes, 22 or 23 minutes, cap it. Look at that, 21. So what this shows is that this is the time after takeoff that we should be at all these different points. So at 26 minutes after takeoff, we should get to our top of climb. So that's actually quite an important number to know. Menley, 28 minutes. We'll get to Cairo after 32 minutes. Alexandria VOR at 46 minutes, etc., etc. And we also get our boundaries as well. So Greek control will occur over here at Tanza, which will be 1 hour and 17 minutes. Any other things? Points of interest, we're going to reach Tirana control at 2 hours and 21 minutes. Belgrade. Vienna. Now, a few points over here as well. So at 21 minutes in, we're going to get to Capit. And this is the minimum fuel on board. Now, remember, we have to add on 1 ton because we took on 1 ton extra. Okay, so if this is 13.6, we're actually estimating 13.7, right? So we would write 13.7 over there and actually check that with how much fuel we're expecting when we get there. So if we look at how much fuel we have on board at the moment, 13.7, when we get to that waypoint, Capit, we're actually estimating 15.1 tons of fuel by Capit. So what's happened there? $14.6. So it's about 500 kilos more than what we expected. Okay, that's okay. But this is the idea, and then what happens is that when we get to Capit, it's going to take us 5 minutes to get to our top of climb. Because 5 minutes plus 21 minutes is 26 minutes. Once we reach our top of climb, 2 minutes later, we'll get to Menley at 28 minutes. 4 minutes later, we'll get to Cairo. Okay, so these numbers tell you how long it's going to take to reach that point from the previous one. Okay. A few other things over here. The static outside air temperature is going to get colder as we climb as well, with a prediction on our ground speed, true airspeed, and wind speed. Mora, we spoke about this before, very important. Minimum off-route altitude. If something happens, 6,300 feet, 10,500 feet, 4,200 feet. This is our distance remaining to go, and that will go down, 2063, 2032, and the top number is how much we've actually flown. So when we get to Cairo, no, that doesn't mean that actually. That means, I think, the leg. Yeah, that's the distance on each leg. So it'll be 31 plus 13 plus 36 plus 63 when we get to Capit. So Capit is quite a long leg, 63 nautical miles. Some of them are much, much longer though, 177. So for instance, when we get to the Vienna control, we'll have 764 miles to go to London. Okay. Now, very importantly, remember at the beginning we had a shear rate of 10.1 by Resti. That's very, very significant, okay? That means an enormous amount of turbulence, almost dangerous, maybe very dangerous weather. So we'll go to Resti in our over here. Resti, here we are. Shear rate 10.1 at Resti. And we can have a look at the other shear rates as well. So they're pretty low, especially with Cairo even. One very low, here we are. So it jumps dramatically as we get to Dimri, Dimi and Resti. Everything else looks pretty good. But then also here, this is a little bit concerning. Gasca. Check anything else. Okay, so the real concerns are Dirami and Resti. We can have a look where they are. Okay, so when are we expecting to reach there? 1 hour 38 minutes in. So that's 1 hour 38 minutes from when we started. Mora altitude 7,800. 2,000, so we're going from a mountainous area to a less mountainous area over here. That all looks sort of okay. The good news is that we'll only be on that leg for 8 minutes, and then only 4 minutes to Resti, and then only 5 minutes to get out of Resti to Alani. So it could just be a very isolated point. We'll have 10 tons of fuel on board, so plenty of fuel. But let's have a look at this. So 1 hour 38 minutes into the flight. 1 hour 38 minutes. The time that we've been going is 23 minutes. Now, normally what we do is write down when we actually took off. But an hour and 38 minutes. And we've been going for 23 minutes. So 23, 33, 15 minutes. So it'll be another hour and 15 minutes. So an hour and 15 minutes. That time will be 02:17. So at 2:17. We might want to, or already around 10 past 2 Zulu time, UTC time, we will probably want to make an announcement on the intercom over here. And we will want to turn the passenger seatbelt signs on as well. So just to make a note of that at 2:17, because we are expecting a lot of turbulence when we get up to there. The good news is that we've appeared to be at our cruise altitude, 33,000 feet. Check our progress, optimal 340. So we can actually go to 340 enter that on managed mode, and that will automatically update our new cruise at 340. And we can type in EGGW Luton, and we can see that we are 1,900 nautical miles as crow flies from London Luton. But 2,100 nautical miles based on our route of actual flying. Okay, because we're not doing a crow flies route. So what we can quickly do now is a quick fuel calculation. Estimated fuel on board will be 4.3 tons. We'll have to add that to our zero fuel weight, 56.4, which we're looking at around just over 60 tons. And since our landing weight maximum is 64 tons or thereabouts, we are going to be absolutely fine for landing in Luton, which is probably no surprise. We're estimating landing at Luton at 7 minutes past 6 in the morning. Local time, that will be 7 minutes past 7. And otherwise, that's all good. So we can check our cruise page. We've got 1,900 miles till our top of descent. And just keep it on progress to maintain, see how we are doing over there. As we start to burn more fuel, as you can see, we've burnt 2,100 kilos, to just over 2 tons of fuel in 26 minutes. As we become lighter, our optimal flight level will increase, so we will probably want to do that. We've got a message from Easyjet operations that have come through. We'll read that later. We are back in the cockpit, and we've been going for a little while now. We can actually see that the timer is on 3 hours and 39 minutes from takeoff. So we've been doing a pretty much soddle in the cockpit for the last 3 hours or so. But anyway, that's how it goes. Nothing really to do. Is the truth of it. Wow, but look, you can see the sun starting to rise over there. Really quite incredible. So, obviously, just want to do a few checks. So, one of the things that we can do is just first of all, quick glance. FOB fuel on board 7.5 tons. Everything's looking fine. The time now is 20 past 4 Zulu, so that's 20 past 5 London time. And let's do a few checks. So in our performance, actually we'll go to progress. Actually it's telling us our optimal is 360, so we can actually do a climb to 360 and set a new flight level. There we go, 360, and the plane will start climbing. So that's the first thing, I guess. Next, we'll go and have a look and do our fuel prediction. So we're predicting 3.6 tons in Luton, arriving at 6:26. The time now is 20 past 4, so just over 2 hours left to go. What else? So, progress performance page, we're estimating our top of descent, where we're going to begin our descent at 5:43, 507 nautical miles. So 5:43 will still be an hour and 23 minutes from where we are. So we've still got quite a long time. What we can do is that we can just go to plan mode and actually just cycle through our flight plan to see where our top of descent really will be. There we go. That's where it's going to be. Between Nogro and Valco. And if we turn our constraints on, we can see that we've got constraints over here at 220 going into Renus. So, I hope you can see that. So, Renus, let's just have a look. This is where we are at the moment. Past Croatia. Is that Serbia, is that? And now we're entering Austria. Our Mora altitude is 13,600, so really over the Alps now. And passing through different sectors of Germany. And we're going to be entering Renus over here. So this is going to be our first constrained at 22,000 feet over the English Channel. And what we'll do, we'll bring that up. So we've got the Renus 1 November that we're going to be going in, and we have to be at 22,000 feet over here. And then we're going to be following the standard terminal arrival with constraints all the way to Zagazoo. Alright? So in order to be at 22,000 feet by Renus, we have to we have to start descending earlier than that, obviously. So that's what's happening at this top of descent. Okay, so if we start descending it over there, the aircraft is saying at our current flight level we'll get to flight level 220 with a cost index of 4, which basically means an idle thrust descent. So it's the most efficient way to get down to Renus. And that's going to occur at 5:42. Alright, so let's go back to where we are at the moment and in arc mode. Otherwise, nothing really too significant. One of the things that we can do is do a quick performance check landing, but we're really too far away to make that meaningful at the moment. So yeah, really nothing much else. EPU, air conditioning. You can see the temperatures, different various parts of the aircraft there. 9.9 tons. That does make sense. So we've burned nearly 10 tons of fuel. And our gross weight is 63.5 tons. So we're now below our maximum landing weight, and it's 65 tons. So if we needed to make an emergency landing, we'd be able to do that no problem. 2 hours. It's just before 7:30 in the morning London time, and we can get a weather report a little bit later on because we are quite far out. So we just really have to wait until 5:42, another hour and 15 minutes before we start making our descent across the English Channel. What we could do is have a look at some views. The sun rising, which is nice. Well, again, really nothing much else to do. So, let's just have a look. Beautiful sky, and let's see where we are up to. Okay. So first of all, we need to turn the PFD displays up a little bit. We've got a deceleration warning, and it looks like we should have started to descend already. So we've actually just missed the top of descent. So we're going to do that right now. We're going to come back down to 220. And because we are so high, and we're approaching Cuckoo, in fact we're approaching Zagzoo, so we're coming in way too high over London, but never mind. So we're coming in over Cuckoo. What I am going to do in this situation is I'm going to take control of the speed. I'm going to dial the speed back, go into an open descent, and we're going to really pull the aircraft back to 220 knots. Then what I'm going to do is, apart from trying not to panic, bring up our charts, and we can enter a hold, hopefully at Zagzoo 149 inbound right turn, and I'm going to do that right now. Hold 149 right turn inbound execute. So we're going to be going into the hold. We're at 220 knots in an open descent, and in fact we can go down to 8,000 feet in the hold, our minimum holding altitude. I believe it's our minimum holding altitude actually. Let's just have a look at the charts on that. So what we can see, so we should have actually entered Renus at 220, and then we would have had a managed descent over here. Anyway, we've got a maximum speed restriction at 220 knots, so I've programmed the EFIS over here for 220. We're then going to be going into the hold at Zagzoo 149 inbound, and we have a warning here saying do not proceed beyond Zagzoo without ATC clearance. So we've got, it says we should be at 8,000 feet over here. However, if you look at the hold, we've got maximum holding flight level 140. So I'm tempted to say we're okay. I mean, we're not really, because we should be at 140 maximum, and we are, oh god, we are at 32,000 feet. Ah, that's not good. Anyway, never mind. Main thing is that we are at 220 knots. Because you see, we forgot to start the descent in a timely manner. One of the things that we're going to do over here again is actually increase the brightness, because it's getting lighter now. And I've actually been working during the night, so that's why I forgot to check the status of the aircraft. But never mind, we're going to be in an open descent. An open descent, by the way, means that we're not going to be listening to any altitude constraints that's programmed into the flight management computer. Instead, we are literally just going to be idling the throttles So we can see here they're, whoops, sorry. You can see they're idle, and we're just going to be in an open descent all the way down to whatever we want, which it will be 8,000 feet in the hold. And I'm also going to time our holding as well, because we added an extra 1 ton of fuel, and that gave us an extra 40 minutes, so just keep an eye on that. Cams are brighter. So we're now configured flying into the hold at Zagzoo. So that's alright. I mean, we shouldn't really be above 14,000 feet over here, but it's pretty quiet. It'd be nice if we actually get some air traffic control coming into London. That would be good. Right. Now that we are sort of getting ready for our descent into Luton, we're really not that far away now. We can start doing our preparations. So the first thing we really want to do, I just can't get over how beautiful the skies are here. First officer's view. You can see the Easyjet wing over there, just over there. Okay, so enough of the view of the clouds. Can't actually see much below that, can you? But anyway, they do look nice. Right, let's bring up our charts, and we can pull on day mode now. Okay, so we've come into the SID, and we are now that's the conventional approach. That's not what we want. We want the Zagzoo. Yeah, okay, so after the hold, we're going to be approaching Zagzoo. And at Zagzoo, we have a mandatory altitude of 8,000 feet before proceeding. And then we are going to follow the pre-programmed route, which is the transition, the Zagzoo 1 Tango transition. And that's going to get us on our approach fix for the runway 25, where we want to be entering at 3,000 feet. Okay. So what we want to do at this point is have a look and actually see what the weather's like in Luton. Rain, well, doesn't look too good. 18 knot wind, 320, so significant rain. Significant wind. And this is what we drew before, so we can see at 320 degrees. So the wind has actually changed, and the wind is now coming in more from over here, like that. I don't think it's really going to change the actual landing runway though, because 320 is at 18 knots. We can see we're still going to be coming in like this, still with a headwind component. Okay, what that means is that you can split that into an arrow going like this and an arrow going like that, and the net effect is something like that. Yeah, which is what we have over here. So we were going to have quite a significant crosswind, I think. So that's just something to bear in mind. But I don't think it's going to change the landing runway. Well, we're going to be going for the correct landing runway. Okay. So if we can confirm that with the information, runway 25. Yeah, we've got a 16 knot crosswind. But at runway 07 we'd have a 7 knot tailwind, so we wouldn't be using that. So it's the correct runway 25. So that's good. What else can we say? The other thing that we have to check is on our taxi instructions, parking stands, take that as well. When we actually come in for the landing, we'll probably be using most of the runway, and again we've got to keep an eye on the weather here. Really is not very good. Very low altimeter, 992. So we're going to set that 992 now. 992, and we'll come down to the MCDU. So make sure you can see everything that I'm doing here. Sorry, okay. So we'll go into our initialization. Could it be there? Performance. Next phase. What did we say it was? 992. That's very low pressure. 992. Standard is 1013, 1013 inches of mercury. So it's low pressure. Wind speed and temperature. 320 at 18 knots. 320 at 18 knots. Transition altitude 6,000 feet. Temperature. The temperature at the moment is 9 degrees. 9 degrees. Dew point 8. 9 degrees. Barometric altimeter 608. I'm not entirely clear what this is used for. Is this the something to do with the barometric altitude? Alright, radio altitude would be for a complete auto land. That's extremely accurate. The radio altimeter measures the height of the aircraft above the ground with a ground radar, but we won't be using that for this approach. So I think 608 is the decision altitude, whether or not we're going to go around or not. So we'll have to see the runway, I think, by 608 feet. I think that's what that means. And the 100 could be the radio altitude. I'm not entirely sure about that. And that's your altitude above ground as opposed to altitude above sea level. Something like that. Okay, what else? Right, now we have to run our performance checklist. So, to do that, we'll have to bring up the electronic flight bag. Runway 25, it's definitely not a dry runway. Maybe more like medium poor. 992, so this is just the metadata being updated. The one thing we have to do is calculate our landing weight. So, that is very important. So, our landing weight will be 3.3 tons of fuel, and we'll add that to the zero fuel weight. So 56.4 plus 3.2 is 57, 58, 59.6. 59.6. This is the most critical thing, because obviously the heavier the aircraft, the longer it's going to need. So this is not looking good at all. Low auto brake with a medium auto brake, idle thrust, maximum reverse thrust. Oh, it's cutting it fine. It really is cutting it fine. Flap full, flap 3. No, we definitely want flap full. Auto throttle off might help a little bit, but we're going to be landing with auto throttle on. Oh dear. Maximum reverse, maximum manual braking, so we might have to use emergency braking. But we can't set that. Well, that will have to be done afterwards. The truth is that the condition of the runway is probably going to be more like this, more like medium. I'm hoping. And we've got our wind, our crosswind component, 17 knots, 6 knot tail. So we should be expecting to fly it to the right, just to maintain our center line. But this is, we want to put the aircraft down hard and as quickly as possible. That's basically the takeaway over here. Now, if we go into our approach, we've got our landing speeds and everything is set up fine. So I think we are good to go. Oh gosh, turn down the my displays there. Gosh, look at the weather here coming in at 11,000 feet. What I'm going to do is turn the landing lights on now. I'm also going to turn the seatbelts on.
Ladies and gentlemen, we will shortly be landing. Please ensure your cabin bag is safely stowed with your laptop inside. Your tray table must be stowed, armrests down, and windows.
Sometimes you can see the reflections of the landing lights in the clouds as well. So there we go.
Please help us by handing
See if those were off. Makes a difference to the. You see that.
The toilets are no longer in service. Thank you. Cabin crew must now be seated for landing. Thank you.
Okay, passing 9,000. We've been in the hold now for just over 6 minutes. And I've extended the flaps by 1 position, and that allows us to have a much lower speed. over here. You see that yellow bar, what dropped all the way down. So it allows us to fly at a much slower speed. That's 2.5. Really doesn't look too good, actually. Gosh. Be good to get down. Now, what I'd like to do is request a weather report from ACARS. EGGW. World Like Meta and a TAF report. So they give you different information. Received messages. Yeah, it's just come in at 6:14. 6:15. Holding for 16 minutes. Weather data. Luton. On the 27th at 5:50 Zulu. So that was 25 minutes ago. Automatic 320 at 18 knots, that's what we've got. 9,000 rain. Broken clouds 800 feet. Cumulonimbus, it's thunderstorm clouds. Temperature 9 degrees dew point 8. QNH 9 at 902. TAF Luton. This is a little bit hard for me to read even. Okay. Rain, broken clouds 1,200. Tempo 27. Is there anything there of gusts of 30 knots? That doesn't look very nice. Yeah, 330 degrees at 18 knots, gusting 30 knots, so very windy. 6,000 feet, rain, broken clouds. Probability, I think it's 30%. Right. Now these two things don't look very nice. I don't think they mean very good weather. Not sure what they mean there. Okay. No, we don't need that. Arrival message. No. Actually. Okay. We got the weather there just in case we need to get back to anything. Alright, we've been holding for 20 minutes. Let's get out of the hold. Exit hold has been armed. And remember that we're going to be entering the runway. Sorry, not entering the runway. We're going to be intercepting at 3,000 feet. So we can go into a managed mode down to 3,000. because that's going to take us all the way over here, and it's going to obey all the mandatory speed and altitude restrictions to 3,000. So I think that's looking good. The other thing that we just want to consider as well is our taxi. Probably going to be using the whole length of the runway, coming off at Bravo and then coming around Bravo to the main apron. Anyway, let's get rid of the charts because we know what we're doing now, and we're coming out of the hold. Managed mode down to 3,000. So you can see over here that it's going to be obeying the constraints. 8,000, 8,000, 6,000. Grim. See the strobe. We just want to be obviously making sure that the constraints are being adhered to. So between here and here we expect the aircraft to start descending because we are in managed mode down to 3,000. Now ideally we'd like some weather radar, but actually that's not possible in Microsoft Flight Simulator at the moment. It can't actually, the way the simulator is run, it doesn't allow any radar systems to work in weather. In real life you'd use it a lot, especially to be able to divert around weather as well. Oh gosh. Wow, this rain is, my gosh. And now we're descending. And the blue line over there is where we should reach 6,000 feet by, even though we've got a constraint over here. Gosh, this really does look rough. Wow, I've never flown into London with this kind of weather. And, you know, we're really going to have to get the aircraft on the ground quickly, probably with a hard landing, because, again, we did the landing briefing and we are going to be cutting it fine, to say the least, with our weight, with our configuration. We'll probably want to be using a maximum auto brake as well. Yeah, you see that's not even making much of a difference. Medium auto brake, maximum auto brake, no difference at all. So we'll use medium, maximum thrust. Okay, we're coming down 6,000 feet. QNH 992. this really depends on the condition of the runway. Yeah. See, Luton doesn't have a long runway. Also, I forgot to mention that the radio navigation will be tuned automatically. Oh, you know what we forgot to do? We forgot to copy the secondary flight plan. Never mind. We didn't need it. Radio nav. So it's tuned to the ILS 109.15 with a 3-degree slope. And that is coming from the charts, obviously. Anyway, oops. This is the one we're on now. So this is where you can see we are. We have a mandatory altitude at 5,000 feet, and then down to 3,000 over here. What we'll do, we'll bring up this chart because I think this is the one we're going to need very soon. Luton information, Easy2612 on the Zagzi 1 Tango transition. Passing 5,000 for 3,000 runway 25. That's just alerting Luton traffic because we don't have any air traffic control at the moment. This is going to be a very interesting landing, to say the least. See what it looks like out the passenger view. Can't see a thing. One very important thing to do now at this stage as well would be to prepare for the go-around, to discuss the go-around procedure. We've got plenty of fuel for a go-around. We've got 3.3 tons over here. 3.3 tons, so we've got it's approximately half an hour, about an hour and a half flying time. We're going to arm the landing system. We can see that our localizer we are getting established. So I'm going to arm the localizer very soon. Kind of just overshot it a little bit. Never mind. Localizer armed. We're going to arm the approach.
2,500.
Now. Okay, so we would expect the aircraft to start to descend. I think it needs a little bit of help. No, it doesn't. It's alright. Yeah, no, it's not alright. Some speed brake, please. Landing gear. Managed. The approach has been armed. Now normally you wouldn't put the landing gear down now, but you could just to help. We're going to have braking. This is a very, very rough. We're reading 200 and no, that's not right. 37 knot crosswind. Okay, this is going to be really, really tough. We normally do flaps 1, 2, 3, gear, and then full. But never mind. And we're passing each notch we pass, we can lower the gear a little bit more. Okay, runway in sight.
1,000.
Full flaps. Spoiler armed. Alert the cabin. Okay. .25 knot.
500.
Feather off.
Hundred above. Minimum
Light
100.
slow.
40, 30, 20. Retard. 5.
Whoa. Maximum thrust. That wasn't bad. Maximum thrust below 60 knots. Thrust is coming out. That wasn't bad at all. I think the runway condition was actually a lot better. We can retract the flaps. Spoilers come off. And we can even vacate on the first taxiway.
Ladies and gentlemen, the cabin crew will shortly be leaving their seats to perform safety-related duties. However, we ask that you remain seated until the fasten seatbelt sign has been switched off. Portable electronic devices for messaging, calls, or internet access may now be used. Please make sure you take all your personal belongings with you, checking in the seat pocket, underneath the seat, and
welcome
in the overhead
to
lockers.
Luton.
Do take care opening the overhead lockers as items may have moved during flight. Smoking is not permitted until you reach a designated smoking area. On behalf of the captain and the crew, it has been our pleasure looking after you today. Our ground
Okay,
crew will
let's
help
start
you
the
complete your
APU.
journey.
Taxi light, runway turn off, on, and turn the APU bleed on. In fact, what we're going to do, we're going to come in at this stand over here. It was actually where I departed from originally. Stand 2-1. Okay, parking brake on. Now, do we have the APU available? Not yet. When it is, I'll be able to shut the engines down. We don't have any ground power yet available, which means the electrical power, so I can now shut down the engines. And we'll still have power from the APU and air coming into the cabin.
Cabin crew disarm doors.
Turn the fuel pumps off. Strobe should have come off after the runway vacation. Beacon can come off. Wing can come off. We'll leave the wing lights on for now, actually. And you know, we'll leave the beacon light on until the engines have calmed down a little bit. Okay, ready to disboard? Yeah, we are ready to deboard. And if we go to the mass and balance, see that coming off over here. So just to actually show you, we can see we're at maximum zero fuel weight we're well below now because we've burned a lot of fuel off. Anyway, so yeah, I hope you enjoyed that. We'll probably have ground power. We have ground power available, so now we can turn the APU bleed off and the APU off, and turn the seatbelt sign off, and we can start exiting the aircraft. Okay, so that is that, and let's have a look at our APU, see how that is getting on. Should be cooling down a little bit now. Well, it's not, but it will come down. Because it is switched off. Packs can come off, and engine bleeds. Whoops. Can also come off too. You can turn the ADIRS off, and the crew oxygen supply can be off as well. And then we'll basically just wait for the crew to and passengers to leave. So welcome to London Luton. It's a very well modelled aircraft. And no one's here. Remember, this is on the live VATSIM network. No one's here at all. So now the engines have calmed down, we can turn the beacon lights off and the taxi lights off. And beacon lights, you just see what that looks like. You can see the difference there. And the APU should have, yeah, it's cut out now. And we can turn the external power off. And then everything's going to go off basically, and our batteries can go off. So there you go. Get a bit of air. Welcome to Luton. The weather, well, it's really like right now, Friday morning, 27th of September.